Hello. Guys, can you hear me?
अब देख खाली आता खाई रही है खीरा से पूरी कौन सा लिया
Yes. Hello, Rohan bhai.
Yes, Amit.
Okay. So you are able to hear me, right?
Yes, I am able to hear you. Can you hear me?
Yeah. Your slides is present. Your camera is also live, and your voice is also coming properly. So we will start now. Okay.
Okay.
Okay. So friends, good afternoon. So welcome to one and all session over here. There are 40 plus participants present here from different parts of India, from different background. Many are from IT professionals as well. So first of all, on behalf of Gujarat Technological University, I welcome you all, and also a warm greetings for the World IP Day to one and all. So during this lockdown period, this is a novel initiative by the Gujarat Technological University to make the IP learning alive. And for the same, and with respect to the celebration of World IP Day, we have, with respect to help from the Mr. Rohan, we have arranged this 1 week long specialized webinar session on the trees. So before Mr. Rohan will start his presentation, I would request and would like to give some basic instruction to one and all for uninterrupted connection and to have a good voice connectivity. Would request all the participants to please keep their microphone on a mute mode so that it doesn't create center request. If you have any question in between, you can post the same into the chat box, or else we will have a detailed question and answer session at the end of Rohan's session. So this is about some basic instruction and introduction about motive and planning of this specialized IPR program. Now coming back to our today's session. So the first session is based on the history of TRIZ, and the same is going to be delivered by Mr. Rohan. So Mr. Rohan is basically a BTech in electrical engineering from Uttar Pradesh Technical University. He holds a postgraduate diploma in patent law from Nalsar University. He is also a registered Indian patent agent. He has worked on different positions at Qtro, John Deere, Merchant Mangalore, Crompton Gray, and Fleetguard Filters Private Limited. He has a total experience of 15 plus years, and he is a TRIZ level 3 expert. So, Rohan bhai, we warmly welcomes you for this webinar. Uh,
Thank you, Amit bhai, for such a beautiful introduction.
yes, we are able to hear you. Please carry on.
Great. Thanks, Amit, for such a fantastic introduction and such a generous introduction, I would rather say. Good afternoon, everyone. Welcome to the first of the lectures in the series of TRIZ sessions that we'll be going through over during this complete week. I have been delivering lectures on IP and innovation related matters, but more of face to face interaction. This is a first of a kind interaction for me on a WebEx meeting. I really look forward to continuing this. I thank GTU for providing me this opportunity. A great initiative, I would say, on behalf of the Gujarat Technical University to take the training agendas a notch ahead and keep people engaged even during this lockdown period. As Amit told you guys, that we will have 6 sessions over the period of this week, and during these 6 sessions, I'll take you across different facets of TRIZ, uh, which I would gently touch upon. We would not be, I mean, we'll not be in a position to get in into the depth of these topics. However, this would be a good enough introduction to get a heads on TRIZ. So let's get started with it. And like Amit said, we would have a detailed question and answer session towards the after the end of the presentation. So I intend to keep it like this. I would start presenting right now, which will go on for about 20-25 minutes. Or the other way that we can do is we can go through half the presentation, take a 5 to 10 minute question and answer session, and then conclude the session and then take another question and answer session. So the other format we will keep for the next sessions when we are getting into topics which are relatively more exhaustive and extensive. For this session, what we do is we would have one complete session, and at the end of the session, you guys can ask whatever questions you have related to the history of TRIZ, related to certification and stuff like that. So let's go through the presentation. Yeah. TRIZ. I call TRIZ a way of life. I don't call this a methodology. It That's how it has been. It has been with me with TRIZ. You know, I have been practicing TRIZ for close to about 10 years now, and as we continue on this journey further, I would like to uh, bring you across the different facets of TRIZ, and just to tell you, I have been using TRIZ in my day-to-day life as well. TRIZ has some very interesting tools that not only helps you resolve technical problems, but helps you resolve personal, interpersonal problems as well. So yes, that's why I say TRIZ a way of life. Moving ahead, this is the week-long agenda. Today is the first session that would deal with the history of TRIZ. To Tomorrow would be the next session that would talk about function modeling, then cost reduction. Cost is one problem that the industries globally are dealing with in one way or the other. So TRIZ has its own way of getting rid of the flab, I would say, cutting the flab and reducing the cost without compromising on the functionality. Then the next session would be contradiction. As TRIZ was perceived, contradiction is considered as one of the basic fundamental ways of problem resolution. Then we move to the after we have studied contradiction, we would move to the contradiction matrix. So in the previous session, when we are talking about contradiction as a way of life, we would be talking about uh, formulating a contradiction. So, we understand that most of the time there is a contradiction, there is some or the other contradiction that's already there, but then it's important to formulate a contradiction in a manner that can give you a direction to the solution as well. Then the next session would be on matrix, the contradiction matrix that gives you directions of resolving contradictions once formulated. And the last session is going to be on the trends of engineering system evolution. Okay, so let's start with the history of TRIZ. Many of you people must have heard about TRIZ. TRIZ has been this name has been in India for quite some time. It's been about 15-20 years, thanks to a few gentlemen in India who got this concept to India, specifically to Mr. Sri Fadnis of TRIZ Asia, who has been practicing and proliferating TRIZ throughout India for the past 15-20 years now. That's about India. But then, how did TRIZ come into picture? We have known this for 15 years. How old is this concept? Just to let you know, TRIZ has been there for a pretty long time globally. We have gotten exposed to it relatively late. Let's go through what exactly TRIZ stands for. TRIZ is a Russian acronym that stands for Teoria Решения Изобретательских задач. Sounds like a tongue twister, isn't it? Yeah, that's what it sounded to me as well like when I started studying it. So, in simple words, in plain English, this is theory of inventive problem solving. But then the word tips sounds does not really sound like something that would help you solve uh, typical problems. That's why we go with the acronym TRIZ. Okay, okay. So that's about TRIZ. The word TRIZ. How did it come into being? And who was the man behind it? So you see a photograph on the right of my slide. This gentleman is Mr. Generic Sovlovich Altshuler. He is called the father of TRIZ, the man
Hello,
who
Rohan.
pretty much. Hello,
Hello, Rohan. Sorry to interrupt. Your presentation is not working. I could see only first slide.
you're not able to see the subsequent slides?
Yeah,
Yes,
Just a moment.
might be. Rohan bhai, share the slides again from the
Okay, I
application.
have to share it again.
Even the
From
audio
the
is
application.
Okay.
also even the audio is also working actually.
Are you guys able to see the current slide right now?
I think it's loading. Yes. Slide number 3, the man and his methodology.
Right.
Please,
I think
please.
when I go to the presentation mode, it
Hmm.
vanishes. Let me know, is it still visible in the presentation mode?
Yes, yes, it is. Please change over to previous of the next slide. Yes, yes,
Yeah,
it's working.
it's working.
Yes, carry on. Would request all to mute their
yeah.
microphone, please.
Thanks.
Okay.
Thanks.
Somebody said that my voice is breaking. Is my voice breaking to everybody, or is it audible to most of the people?
Yes, sir, it is breaking. but where it is audible, like we can get what you are speaking.
Audible,
Yeah,
audible.
I am trying to speak slowly because I understand that the data connectivity would not be great in all the places. So I'm trying to speak as slow as possible so that the voice transmits and there is no overlap as such. If you guys have any specific issues related to the voice, do let me know. I will slow down further. As it is, it's afternoon. If I slow down a lot, you guys will start feeling sleepy, and so would I, isn't it? Okay. Moving to the next slide. I am hearing a lot of message tone. Are people sending messages here? All set, everything visible and audible. Should I go ahead?
Yes, Rohan bhai, we are very well able to hear you and listen you properly, and we are
Great.
able to see your slides too.
Okay, great. Okay, so I was talking about the man and his methodology and the acronym TRIZ. So, Altshuler was the man who propounded TRIZ. He was the man who formulated the methodology right from scratch and brought it to a position from where his disciples have taken forward and they are still further developing the methodology. Okay, so that's about Altshuler. Let's delve into his history a little more. A very interesting gentleman, a man who had his first invention in the eighth grade, a pretty young age to develop something, isn't it? Hello,
Yes, we can hear you.
you can hear me now?
Yes, yes, yes.
Uh,
Please.
this thing has kind of gotten me a little conscious, It's okay.
Please make the slide in a presentation mode, Rohan bhai.
Oh, it's not in the presentation. Wait,
No.
just huh.
Yeah.
Okay.
Now, okay.
So,
Yes.
yeah, uh, generic Altshuler was uh, born in Russia, or I would say undivided Russia, which is USSR. Okay, and in the eighth grade itself, he made his first invention. Uh, his first invention, his first invention was related to a diving apparatus, a water diving apparatus using hydrogen peroxide. So, uh, rather inquisitive guy right from an early age, who would tend to look at things beyond the way they would look at the outside, and would always try to explore stuff. He was born in Baku, a small town in undivided Russia, and he went on to live there for a pretty long time. Uh, After having done his eighth grade, uh, he got his first. It was called as author's certificate back then. It wasn't called as a patent in those days. It was called as an author's certificate. So he received his author's certificate for his apparatus that is developed in eighth grade. His first author's certificate. And since he was such an inquisitive guy, at one point of time he was recruited, and in fact, not even after graduation, after doing his 10th grade. And in those days, Russia, it was called as, he graduated after doing his 10th grade, he graduated his 10th grade and he was recruited with the Russian Navy. And knowing his inquisitiveness to learn new things, there's this thing that people generally talk about that Altshuler was a patent examiner in the Russian patent office. Actually, I also used to think about the same at some point of time. But then, as I got more interested in TRIZ and I started digging further, I got to know that he was not actually a patent examiner. He was a guy who was recruited by the Russian Navy and he was working with the patents department of the Russian Navy. And his primary job was to teach people how to invent. So, by the time he started working, he already had about 2 to 3 inventions under his name. So, he was recognized as a person who would try to generally solve problems. And he was recruited in the Russian Navy so as to improve the uh, innovation quotient of the organization. On the right hand side of the slide, you see two photographs. The photograph on the top is the young Altschiller who actually received the author's certificate, his first author's certificate. And the bottom right hand corner is when he started working in the Russian Navy. A rather inquisitive man, at a time when psychologists wanted to study inventors to understand how do inventions happen. This guy was studying inventions and not inventors. He said that the solution to finding out how inventions occur would not really lie in the mind of the inventors. It would probably lie in the inventions that have happened over the past because inventions have their own way of surfacing. So he was at that point of time itself trying to study inventions as they were happening to derive a pattern out of it. So, and he did this work for a pretty long time. And since he was a part of the patents department, he had access to the patents that were being filed by the Russian Navy and other patents as well. He did a pretty extensive study to understand what are the kind of patents that are being filed, what problem statements are being dealt with which specific patent application, how are the problem statements defined, how is the solution being arrived at. So he was forming his own hypothesis as to how inventions are shaping up. And he would do that with bunch of applications. And then and when he actually thought that he had kind of a methodology where he can actually say that if you follow a certain specific process, you would be in a position to invent quite a lot. So along with friends who work with our writer to start USSR continent at that time. And we're talking about a time right of Second World War, when the things were not very good politically. And it took him to write about 2.5 years one letter to Stalin. He, along with his friend, wrote that letter for a period of 2.5 years where they enumerated the various shortcomings that Russian inventions had and how the state of inventive activity in the country is very poor. How can that be? The two friends got onto this mission, studied the inventions, wrote the letter, and sent it to Stalin. Now, the way it was in those days, this was considered a crime against the state. Now, highlighting that the state is not in a good position, highlighting the shortcomings of the state, that was considered a crime. So, interesting, isn't it? Somebody who's telling you that you're probably doing something wrong and this is the right way of doing it, he was never expecting such a reaction. But then, that's what the geopolitical condition of the world was at that point of time. Instead of being rewarded for doing something great, he got arrested. So yeah. And back in those days, there was this culture of concentration camp and labor camp, thanks to Hitler, that this culture had come in. So he was arrested in 1950 and he was sent to the Gulag labor camp. Arrested and sent to the labor camp in those days, it was pretty much considered as the end of life. And at a young tender age of 22 years, 24 years, sorry, he was born in 19. 26. And in 1950, at the young age of 24 years, when you really started working and you thought that you are doing something great, and you have derived a methodology for improving the innovation quotient, you are getting arrested and you are being sent to a labor camp and sentenced to 25 years of rigorous imprisonment. That's very ironic, I would say. But then, yes, that's how it was. That's what happened to that. He was arrested. He was sent to the Gulag labor camp to serve 25 years of imprisonment. His father had died. His father had died a little earlier, and his mother tried fighting for him. And when the petition for pardoning him was actually not allowed, uh, so his mother actually committed suicide after she received a refusal to her petition for pardon. Actually. So a very sad demand, where because of something great that you were doing, your family is reached to such a condition. But then, alas, that was not to be the fate. After Stalin was removed from position, he was released and but then actually keeps during his times in the Gulag labor camp, he met a lot of scientists, innovators, industrialists who were also imprisoned as straight prisoners in the Gulag labor camp. And they would, come sit across, try to teach each other something or the other. So it was like, if you continue to do what you really like, you can pass through even the rough patches of it. So we have a lot to learn from this student, not just TRIZ. TRIZ is one very good methodology that he has given. There is a lot to learn from him. In the times when we are talking about a lockdown, trying to understand the journey of a person who was not locked down, who was in prison, but he still continued his quest for finding a way to make the world a better place to live in, for finding a way or a methodology to innovate, or finding a way to make human race better, where he says that he has a very core belief uh, that there has to be a specific methodology of innovation. Back in those days, innovation was considered as a spark of a genius. It's a spark that comes. But then he was the man who was going against the tide and who was saying that it's not a spark of a genius. You go through a certain process, and when you arrive at the destination, you say that it was the spark. But then you have actually gone through a certain process. And if I document the process, if I make it public, everybody will be in a position to do it. So yes, even during his difficult times in the Baku concentration camp, he continued his research on TRIZ. And since he was imprisoned for 4 years, he actually invested a lot of that time studying a lot of patterns, learning from people who were there in the camp with him. So that when he was released in 1956, he published his first article where glimpses of TRIZ were given. The article was named About Technical Creativity, and it was published in the Journal of Questions of Psychology. Interesting, isn't it? Because at that point of time, psychologists were the one who were interested with studying the minds of inventors so that one can derive how inventions happen. But nobody really thought that studying inventions rather than inventors would lead to a stage where you would identify what exactly is it that leads to the life of a new invention. So that was pretty much the timeline when he first introduced TRIZ to the world in 1956. The slide that you see here gives a brief glimpse of how has TRIZ proliferated through the world in the days to come. I would rather want to take you guys through this slide before we go further, because this gives a clear timeline what happened in like 1960 for his work and continued his research. Up to 1960, he had formulated technical contradiction. He has postulated that technical contradiction is a way of innovating. So these were the three. On the left hand side, you see these three uh, methodologies that he has postulated by that time. The first being technical contradiction, which is still in use today, just the way he developed. Then the multi-screen thinking, the nine-window thinking approach that we talk about, which is also still being used today. Then IFR, which is also called as the ideal final result. During 1960, 70, and 68, quite research on this, only for the reason that 1960s is the time when uh, Altshuler actually gave up. He gave up working full time, and he did it to earn his living by writing. So, for the knowledge of those who don't know, Altshuler was also a very famous novelist. He has written a lot of science fiction novels. So, yeah, that's another uh, aspect of this great man's life. So during the 60s, he had given up a full-time job, or rather, I would say mid 60s, and he had taken up writing, and whatever time he would save from writing, he would dedicate that time to the improvisation of films. His pen name was Generic Alto. Just for the interest of people who would like to learn a little more about it, you can look at his pen name, Generic Alto. He's also featured as one of the best all-time writers in a lot of forums. So by late early mid 1960s, Generic Altshuler had left job. He dedicated all his time to develop TRIZ. He developed ARIZ between 1960 and 70. Then he introduced the contradiction matrix during that time, method of focal objects, inventive principles, which we today know as substance field analysis. There are 76 inventive principles that are there. So during 60s and 70s, he did that. During 70s and 80s, he worked further on his inventive standards in ARIZ. ARIZ was developed further, and then this version was known as ARIZ 85C. That's the version that we use even today. By that time, 76 inventive standards had come up. That's what we use even today. At that time itself, he had propounded that engineering systems evolve in a certain manner. So, laws of evolution had come into picture by that time. And I can hear a lot of echo. Am I audible, guys? Or there's something wrong with the microphone?
We are able
Hello?
to hear you. Yes, echo is coming. We are trying to sort it out.
Okay.
Yes.
Okay. So yeah, as we see in the timeline, by 1980s, TRIZ was pretty much in a very developed stage. Now they had actually come to a conclusion that there are certain steps that had been postulated and formulated. If we follow this, problems can be resolved. Innovation can be done. So between 80s and 90s, ARIZ 85C substance field, and then there is a very interesting new addition that happened between the 80s and 90s. That's called as the function cost analysis. So by this time, after having developed ARIZ 85C substance field analysis and laws of evolution, Altshuler concentrated his efforts towards, you see a very interesting title, the fourth one from the top, theory of creative personality development. So he started studying personalities and through creative personalities to in order to make a personality. disciples were left to work further on developing the methodology of TRIZ. That's when the disciples, and of course in sync with Mr. Alschuler, they gave the name TESE to laws of evolution. There's a very interesting story to it. When laws of evolution had come into picture, it was thought that innovation moves in a linear direction in this direction. But when they started analyzing more and more data, they understood that the line for straight, it's pretty much the same trend line that evolution follows, but it follows in both directions, forward as well as sometimes from forward it comes to backwards as well. That's when the name was changed from laws of evolution to trends of engineering system evolution. So that's what happened during between 80s and 90s. And by this time, there were a lot of softwares that had come in place. You mentioned machine and mentioned workbench. Uh, there's a gold fire innovator that you guys may, if there are patent professionals sitting here and attending this session, we must have heard of gold fire innovator. Yes, gold fire innovator was amongst the very first softwares that was developed by the TRIZ community as such. The TRIZ community went on to develop softwares to explain TRIZ to the world. Now, if we go a couple of slides back, here we see this is where TRIZ was being propounded. Okay, so and what is interesting to note is TRIZ was completely developed in the Russian language, and the Russian language was understood by a handful of population. So, in order for it to proliferate and spread across the world, there were two basic requirements. One, these TRIZ masters, who were basically Russians, should migrate to other part of the world and explain TRIZ to the people. And two, these texts need to be translated in languages other than Russian, like English, Spanish, German, Korean, and so on and so forth. So, on the right hand side of my screen, you would see that there is a specific timeline that's drawn. So when these guys actually and the post-Soviet era during the 90s, the economic condition of those countries were not really great. So it was actually needed for these TRIZ professionals to move out in order to earn their livelihood as well as to proliferate TRIZ. So the first position, and they always knew that they will have to move to those countries that are more bent towards innovating. One of the greener patches for them was the United States of America. So quite a few TRIZ masters migrated to the United States of America. That's where one of the first companies was found, which is called the Invention Machine Incorporates or Invention Machine Corporation in the United States of America. And then the Ideation International was found in the US. The Ideation International is still in business, okay? And they have their one more version of TRIZ that's called as the Ideation TRIZ. So when they had to move out, they thought that the corporates in the industries, they need to recognize TRIZ. Unless they recognize TRIZ, it will be difficult for us to reach this methodology and spread it to the world. However, the corporate environment does not allow you to take a lot of time out for training. They would rather want results. So that's when they decided that we will club this whole body of knowledge into a software, and we would try to sell this software to the corporates and tell them that this software helps you innovate. And that was a very fantastic business idea, to tell you, because amongst their first few customers were people like Airbus International, Boeing, Xerox Corporation, Hewlett Packard. There were many big wigs, Intel Incorporated. There were many big wigs who actually took to this and who said that, okay, fine, if this helps me innovate, I would rather want to understand this. So that's where proliferation started in universities like in the Coburg Technical University of Germany, Wayne State University, US, Strasbourg Technical University, France, the Twente University of Netherlands, and then were a lot of TRIZ companies that evolved. So now they had moved from developing software to help you innovate to organizations that would produce innovative products. So the culture of, I would say, startup was not even very, profound those, but still this community had this culture of startups wherein common organizations develop a few products, sell this product along with the to other organizations. So they started making TRIZ companies, Pragmatic Vision, TRIZ Solver, and then during this time, an Altshuler Institute was formed in the United States of America to teach TRIZ to the people in the United States of America. By this time itself, they felt the need of an association. So there was already a Russian TRIZ association. So by this time, the Russian TRIZ association was re-christened as the International TRIZ Association and was renamed as MATRIZ as we know it today. So MATRIZ is the central body that gives out TRIZ certifications to people around the globe. When I say that I'm a TRIZ pre-certified, even I am a TRIZ pre-certified by MATRIZ. So MATRIZ is the one that gives out certifications, and they are the ones who still govern the teaching of TRIZ, the methodologies, the way they are to be taught. So by this time, MATRIZ had come in 2000. European TRIZ Association was formed by one of my previous guides or teachers, I would say, who has taught me TRIZ level 2, Mr. Valery Suchkov. He formed the European TRIZ Association, and then a lot of associations started emerging. That was the fourth stage of proliferation. When these associations would emerge, they would learn and they would teach further. So you see the TRIZ Association of Asia here. That's the TRIZ Association that manages TRIZ-related activities in India. So by this time, there was the France Association, there was an Italian association, a Japanese association that came into the picture, the German association, the Asia Association. By that time, TRIZ had moved a lot to Malaysia, so the Malaysian Association. So this journey, the methodology as such, this is how the methodology moved forward. Now, TRIZ, as we know today, is the modern TRIZ. There was a part of the classical TRIZ, and there's a part of the modern TRIZ that has come into being. So when TRIZ was being formed as a way of solving problems. So when there was a technique that was used to solve a problem, that was in early 1950s. So timeline says that first method was approach to solve problems. Then the supplemental methods to support the solving of problem was found. Then there was a few methods that were there, like 2 or 3 different steps that were to perform, 3 different that were to be done to solve a problem. Then a proper algorithm came into picture, which said you need to read these 10 different steps or 5 different steps, one after the other, or iterative, or in what fashion. An algorithm came into picture. When an algorithm came, when we say ARIES. So ARIES was a specific algorithm, but then there were certain more parts to it, which were actually very useful. So there were certain parts which were not a part of the algorithm, but then they were still very important and integral part of solving problems. So this ARIES was one way of solving problem, but the technical contradiction or physical contradiction way was another one more way of solving problem. That's when they started making it a theory, an applied science or a theory. Then TRIZ had to evolve further. There were set of theories being formed, and then finally spheres of business, moving to different spheres of business. So Like we see here, I had told you guys the history up to this point of time. This was up to the year 2000. After the year 2000, some very interesting developments that took place. And purposely I had not spoken about it because in this slide, we see about the spheres of business being covered after the year 2000. So after 2000, a very important tool was introduced, which was called the root cause analysis. And then another very methodology that was propounded, that was the alternate system hybridization. So a relatively quick way to innovate, wherein you bring in the good points of one product and marry it with another product where this was a shortcut. And there are ways of doing it. Then up to now, TRIZ was being used as a methodology for innovation for the scientific and the technological sphere of life. After 2000, TRIZ for business and TRIZ pedagogy was improved. TRIZ for business now started taking TRIZ into the spheres of service industry, where TRIZ would be used and implemented in the banking industry, in the insurance sector, the healthcare sector, and stuff like that. So now TRIZ started, I would say, TRIZ started going further deep into the theory of problem solving. So now it does not only solve the problem of the technological domain or the engineering problem or the scientific problem, it further started solving problems of the business domain. And then there were two more very important tools that were identified: function oriented research and failure determination, something that would help you predict failure right at the very beginning. So these were the two tools that were formed after the year 2000. And this is a very interesting example of moving from the classical TRIZ as we knew it, where we were talking about ARIES, the trends of engineering system evolution, the substance field analysis, 76 standard inventive solutions, 76 inventive standards, known problem solving and scientific databases, to the modern TRIZ slowly. The classical TRIZ told you the ways of identifying the right idea to solve an initial problem, identifying ways and methods of solving a specific problem. But what the modern TRIZ does is a lot more than that. The next step was at that point of time, the earlier era, it would help you to solve a problem which existed, and you were not very sure whether that's the right problem or not. That's what TRIZ experts identified and said that we also need to find ways of identifying the right problem. That's where it moved to the next stage, where they said that the identifying the right problem to be solved is also being done by the help of TRIZ, and that's where function analysis, value analysis, flow analysis, cause and effect chain, trimming, these things were introduced. Now, these are problem identification tools. When you do a function analysis, you try to identify what the problem is. When you do a flow analysis or a cause effect chain analysis or a root cause analysis, you try to identify what is the root of the problem, not trying to find out how to eliminate the problem. So they said that first we will try to find out what the problem is, then we will help you solve the problem. Then it moved to the next stage, where it started talking about identifying the right systems to be introduced, to be improved. Then it moved to the pragmatic S-curve analysis, the benchmarking. S-curve analysis basically tells you which stage is the innovation in right now. How much time would it take for the how much time can the innovation sustain in its current state in this given stage? What should be the next stage of your product? These were the things that were being told by their curve analysis. Benchmarking would not only be, TRIZ benchmarking is a whole lot different from the general benchmarking that we do. We will talk about it later. Innovation portfolio analysis, function oriented search came into picture, where you talk about two different objects doing the same function. So it tells you that when you have to innovate in a certain area, if you have to innovate, for example, in pen, you don't only need to look at pen. You need to look at all the apparatuses that perform the function of a pen. Now, what is the function of pen? We will learn that further when we talk about. And then supereffective analysis, global knowledge network came into picture. And then the current stage, when it started talking about identifying the right goal to be achieved, when we talk about the main parameter of value, MPV that you see here, the main parameter of value analysis. When you are selling a product, every product has a main parameter of value. Main parameter of value